I think we are ready to start because I can see that the great part of attendees has joined us. Let me remind you again of the possibility to ask questions through the square with the question mark over it. I will see the question and I will ask them to the speaker at the end of their presentation. If you are here, probably you know that today's webinar is about waste as a resource. We will have waste that we will deal with will be vegetable and fruit wastes, rice, and exhausted oils. This will conclude the first part of the webinar, and after that, some very insightful intervention will discuss industrial case studies and business model for business coming from organic waste. So let's start for the first of our speakers, Dr. Doria, who will be from my university, University of Pavia, and who will present on sustainable recycling on vegetable and fruit wastes to recover photochemicals with nutraceutical and or cosmeceutical properties. I forgot to mention that not only is a researcher of University of Pavia, but he is also the founder of a BioRestart, an academic spin-off of our university. So let me allow you to share the screen. Yeah, just a minute, sorry. Here, you should be able to do that, Rao.
Yeah, now the link is right.
Yeah,
please tell me if you can see the screen.
We can see the presentation perfectly.
Okay.
You can go.
The only thing, okay, is I see the now myself. I don't know. Okay.
No, we are looking at your presentation perfectly.
Okay. But okay. Just a minute. Okay, I can't remove the panel on my right side. How can I do?
You can hide it by pressing the orange button.
The orange button, yeah, but okay, maybe now. Okay, now. Okay, good evening to everyone, and thanks for the opportunity to talk about our project. It's called Fiverr, about the sustainable recycling of food waste and co-products in order to recover bioactive compounds and phytochemicals. So the main goals of our project regarding the valorization of the large amount of the organic waste derived from the agri-food industry, a waste which has the high management cost, and it can create also possible environmental and human health risk. So why is it important to valorize this waste? Because in this way, we can reduce the loss of the biomolecules contained in the plant waste material. And the other important goal is to guarantee the sustainability of the project, especially developing a proper extraction process and planning also the reuse of the residual waste. For example, using this for the regeneration of the agricultural soil or obtaining bioenergy like biogas. So the project was born from the collaboration between the pharmacology lab at the University of Pavia and the consortium AOP1 Lombardia. Then, with the support of the plant biochemistry lab of the University of Pavia, the project was funded by Regione Lombardia with the Rural Developing Program 2007-2013. So the promising results obtained at the end of this study work represent the preliminary basis for continuing and developing a pilot project, also deservedly funded by another rural developing program promoted by Regione Lombardia in 2014. So right at this stage, in the transition between these two phases, so we evaluated the possibility to develop an entrepreneurial project, also considering that the markets of food supplement or cosmetics or medical devices in which our extracted product should converge is constantly growing, is rapidly growing. Then finally, in 2018, we focus our attention especially on the technological advancement of our project, improving the extraction process of the bioactive compound in a sustainable way and in line with the circular economy principle policies currently in vogue. This is why also this project was funded by Cariplo Foundation. So the large amount of food waste which is produced every year all around the world is mainly due to some important factor, like the increase in the world population, the great availability of fossil energy source, the economical and cultural diffusion of mass agro-industrial system, the transformation of food lifestyle, and the assignment of a relative low economic and social cultural value of food. By the way, little attention looks to be paid to this important topic like the global food supply chain loss. Then, despite the food waste is important, is a key determinant of the loss of the biodiversity, the accumulation of greenhouse gas, the pollution of water, soil, and other resources. So, keeping a balance between the future demand of food and the supply and the food supply will be the next challenge. Anyway, the food loss and waste is generated all along the food supply chain. Especially in particular, we can say that around the 54% of the total food loss is generated upstream the food supply chain during the field work and the harvesting and post-harvesting, while the 46% occurring during the downstream of the supply chain, especially during the processing, the manufacturing, the transport, and the distribution. Anyway, the most important thing is that this total waste, this amount of waste generated throughout the supply chain should be enough to satisfy the nutritional need for 1 billion of people. According to some data of the FAO, more than 1 million of tons of food is lost or waste every year all around the world, corresponding nearly 1/3 of the worldwide food production for the human consumption. Regarding the fruit and the vegetable waste, almost the 70% of the waste is generated downstream the food supply chain. So if we have a look to the Italian situation, more than 15 million of tons of food waste is generated every year. And in particular, in the Lombardia region, this number is around 2.5 million of tons per year. So we know that food waste has an important impact on the world food system, on the food safety, on the food quality, and in the environmental protection. So this is why recently several scientific reports focus the attention of some topic like the strategies for the reduction of waste production, the valorization of co and byproducts, and the improvement of waste management. So this increasing attention, we can say that should be due to some reason, like the growing environmental concern, the necessity to minimize the impact of the waste on human health, the high cost of waste disposal, and the growing awareness of the benefits deriving from potentially marketable components which are present in the waste. So, in line with the roadmap traced by EU, there is a growing interest in the valorization of the agro-industrial waste because it represents an important source of high added value product. This also because this source is abundant, is renewable, is inexpensive, and most of all is not in competition with food. So this is why reducing the food waste through the recovery of this bioactive compound represents an important way to increase the sustainability of the whole food production system. But there is another important point we have to take in account regarding the sustainability of the extraction process. Because even in the process of the recovering of the waste, the reduction of energy and the optimization of raw material can significantly reduce the cost, and on the other side increase the environmental sustainability of the food system. Anyway, the development of this sustainable and safe recovery method of these phytochemical compounds from the waste must take into account several parameters, several important parameters, like the abundance and distribution of the food waste, the development of methodologies that provide the highest recovery yield, the utilization of green solvent, the preservation of the functional properties of the selected compound, the waste minimization prior to the recovery process, and the last but not less important, the development of qualitative products with a constant concentration of target compounds. So this is why the research is recently needed into the application of the environmentally friendly, traditional and more modern and advanced technique with low production cost in all the phases of the production, like extraction, isolation, and purification of the bioactive compound from the waste, with the important target of the high yield and the maximum quality. So now the research is focused to find the best extraction method. So we can distinguish conventional extraction method, mainly based on succinate extraction, sonication, and maceration using organic solvent. But we can't consider this an environmentally friendly system, because all these methods are based on the use of toxic solvent, toxic for the environment and also for the operator. So this is why recently innovative extraction methods are set up and developed. Here you can see a list of very recent new and advanced techniques. Among them, I would like to underline the enzyme-assisted extraction. Among them, enzyme-assisted extraction represent one of the most eco-friendly technique, because also it offers several benefits like rapidity, maximal yield, minimal solvent, and energy consumption. So this method is mainly based on the use of plant cell wall degrading enzyme. These enzymes are able to deconstruct, to weaken the plant cell wall structure, favoring, allowing to the bioactive compounds to be released more easily from the structure in which they are encased. So this is why in our lab we propose an innovative pre-treatment procedure and extraction system. An extraction system based on this Bacillus subtilis strain, recently developed by Professoressa Cinzia Calvio in the Department of Biology and Biotechnology of the University of Pavia. The characteristic of this strain is that it can overproduce this degradative enzyme, and moreover, this strain is also able to efficiently grow in a residual plant biomass. So the scheme of our process should be summarized in 3 steps. The first step is the growth of this bacterial strain in this medium, in this residual plant biomass medium, for example, the rice straw medium, consisting on rice processing waste. The second step is the collection of the medium rich of this hydrolytic enzyme, of this mixture of this hydrolytic enzyme. And the third step is the incubation, is the maceration of the food waste with this bacterial supernatant. So at the end of this pretreatment stage, the vegetable residue is then placed in a particular kind of extractor filled with water in order to continue and improve the bioactive compound extraction. So we obtained some interesting results using several vegetable residue from which we extracted a relevant amount of phytochemical compounds. So the waste after the enzymatic pretreatment is placed in this extractor, as mentioned before, in order to perform a sustainable non-conventional extraction. After which the plant residue is analyzed for the heavy metal content and for the methanogenic potential to be used in anaerobic digester, for example, for the biogas production. Otherwise, if the residue is particularly rich, contain the high amount of reducing sugar, it should be used, for example, for bioethanol production. In a way, we focus our attention on the cruciferous plant residue because they represent an important source of important phytochemicals like polyphenols and sulforaphane, endowed with a lot of biological activities. But in general, we selected several plant waste which represent a source of different and important secondary metabolites endowed with a broad spectrum range of biological activity, as you can see here in this image. But in particular, among the great variety of these secondary metabolites, we focus attention on a small group of these metabolites, like polyphenols, carotenoids, and isothiocyanate, which are compounds rich in sulfur. So by using this innovative extraction system described before, an innovative and sustainable extraction system I described before, we can obtain a very concentrated extract rich in this bioactive compound, which can be used in the market of food, of cosmetic, or drug. So I complete my presentation, and I would like to thank all the people working in our lab and all the people collaborating to this project. Thank you.
Thank you, Enrico. Right now, I don't see any question, but I have one concerning the timeline of the project development. I could see in your presentation that this began quite a lot of time ago, and right now I know because we work together that you are ready to go to the market, at least to found your spin-off. Would you like to comment on difficulties? So it was just because at the beginning it was just an idea and it took time to reach this level, or which kind of difficulties did you encounter?
But of course, the difficult was several, and so we proceed step by step. Of course, at the beginning, the first stage was to study, for example, the storage condition of the waste, because we want to be sure that the frozen condition don't interfere with the biological activity and the concentration of, for example, of some secondary metabolites. And also, we spend many months for the identification of the best, of the most suitable vegetable waste can be used to extract some important and interesting bioactive compounds. And then, of course, we, as I said before, in collaboration with the Professoressa Calvio, of course, a lot of time is necessary to set up to improve this pretreatment based on this Bacillus strain, able to produce this degradative enzyme. So we have to find the optimal condition to perform this pretreatment. So of course, many years are necessary to arrive at the final stage.
Well, in the meanwhile, a question came, which is the amount of the extract? Are they used mainly for cosmetics or better for nutraceutics? They asking just for an example.
Yeah, the concentration I can't say, because of course we use several waste material, starting material, but I can say that we are satisfied of the concentration, the obtained concentration, because it is not so far from the concentration obtained using organic solvent. So this is meaning that our method can efficiently work, of course, using if our aim is the extraction of polar compounds like polyphenols, I said before, or isothiocyanate, less efficiency is if we want to extract carotenoids, which are less polar, no, less hydrophilic compound. And the second question was about the cosmetic or
yeah, probably they asking if they are mainly these extracts are mainly used for cosmetics or for nutraceutics. Their application, I mean.
But the application, I mean, should be is more suitable for nutritional purposes, but also cosmetics. The polyphenols are widely used also in cosmetic preparation. Of course, isothiocyanate, no, it's more for is principally used in nutraceutical field. Carotenoids, for example, both, because many cosmetics are based on carotenoids, of course. So it depends.
Okay, thank you. I think it's enough. I think we are now ready to welcome our second speaker, Dr. Ravasio, Nicoletta Ravasio, who's a research director at the Institute of Chemical Sciences and Technologies of our National Research Council. So I will, Nicoletta, we cannot see you, but I know you are there.
No, I'm here. I'm waiting for the.
Yeah. Okay. Just leave me a minute here. Okay. Done. You should be able to present now. Okay. Dr. Ravasio will speak about from waste to resource, the RISE project.
Can you see the presentation?
Perfectly.
Okay, so thank you, Lucia, for both the invitation and the introduction. Thus, in this presentation, I will try to show how we can transform waste and even waste of the waste, as we will see, into resources for different markets, from green building to nutraceuticals. Rice, as all of you know, is the staple food for more or less half the world population, particularly in Asia. But its cultivation is also strongly settled in Italy, where it influenced both visual arts and, of course, our famous cuisine. But processing, rice processing produces also a relevant amount of waste. 200 kilos of husk and 70 kilos of bran for each ton of white rice are produced, besides more than 1 ton of straw left over in the field. All these wastes are not easily valorized for the production of energy because of the high content of silica. So some of them is also a relevant environmental impact, in particular straw. But from rice, we can obtain a valuable oil. So starting from this consideration, we began to design our project, the RISE project, funded by Cariplo Foundation and with the participation of University of Pavia, University of Milan, and 2 institutes of Siena. In this project, that was also mentioned among the 100 best Italian circular economy stories in the ENL Simbola report in 2018. In this project, we upgrade all the waste of the rice productive chain by valorizing the chemicals they contain. That is cellulose in straw, lignin and silica in husk, sterols, oil, and proteins in the plant. From, can you see the presentation well?
Yes.
Okay, so from straw, we set up a process to produce insulating material from both the thermal and the acoustic point of view. for green building by mixing the straw with waste wool. Wool is a waste. Wool is a waste because ships are raised in Italy for the meat, for the milk, but the wool is not suitable for textile. So it's a waste, it's a special waste, should be disposed according to this regulation, and in particular cannot be burned because it contains sulfur, and the sulfur dioxide would in turn produce acidic rains. Burning of rice straw is also being phased out in many countries as it produces a huge amount of particulate and also VOC and other polluting gases. As an alternative, the straw is still back into the field, and when the paddy is flooded again, it produces methane. This practice accounts for 12% of the global production of methane. That is a greenhouse gas, of course. But these two wastes can be compounded by exploiting the different behavior in alkali. In a slightly alkaline solution, the wool protein of wool partially hydrolyzed, producing an adhesive matrix that sticks onto the straw fiber, producing a mechanically strong material. If we compare this material we obtain with polystyrene, which is the very common use as an insulating material in building, and with wool, pure wool blankets that are also used in green buildings, we can see that our material are freestanding. That is a valuable feature for the builders. They have an excellent fire behavior. They are fire retardant class 1, whereas polystyrene is highly flammable. They are also sound absorbing. The alkaline treatment makes them resistant to moth and molds. That, of course, is not true for a poor wool blanket. These materials are perspirant, suitable for anti-seismic building, and the insulating power is better than that obtained with pure wool. The thermal conducibility value should be as low as possible. Of course, it's not competitive with polystyrene, but it offers very many advantages. From husks, we obtain several types of biofillers. Micronized rice husk was used compounded with polypropylene to produce material for food packaging. Lignin extracted from husk was used in composites with bioplastics such as polylactic acid and polyhydroxybutyrate, thus producing 100% bio-derived composite. And the controlled combustion of husk allowed us to obtain silica particles covered by the carbon residue. This biofiller, when added to, in this case, to polypropylene again, increase its thermal stability. As you can see, the addition of 20% of this biofiller increased thermal stability by 20 degrees. But let's go to the more valuable waste, that is bran. As I mentioned, from rice bran we can obtain an oil. This oil has a severe drawback, and in fact it's not only 20% of the global production of bran is extracted to produce oil, mainly in India and Thailand. Why it is a drawback? Because soon after its extraction, it becomes more and more acidic due to the presence of an endogenous lipase that hydrolyzes the triglyceride, that is the oil, into free fatty acid. This is a severe drawbacks because this oil cannot be used for in food, of course, because it's too rancid. But it is useless also for oleochemicals production, because to produce surfactant or lubricants, we need to use either free fatty acid, the starting material, or pure triglyceride. So in this project, we set up two different processes. One, bioenzymatic catalysis. So by using immobilized Candida rugosa, we could obtain almost pure free fatty acid from this acid oil. Whereas by using one-pot chemical transformation in the presence of heterogeneous catalyst, we obtain in one pot, in one step, a mixture of mono and diglyceride. This kind of mixture is very well known as an emulsifier and almost ubiquitously present in the labels of our foods as with the code E471. In this particular case, we will obtain a 100% plant-based emulsifier that will be suitable for use also for vegan, halal, and kosher consumers. But in the oil, we have also gamma oryzanol. Gamma oryzanol is the mixture of ferulic esters of phytosterols. This mixture has anti-cholesterolemic properties, and it can be used also in cosmetic product. But we can also hydrolyze these esters to obtain the pure phytosterols. In turn, these phytosterols can be esterified with, again, with a heterogeneous catalyst and the fatty acid we obtained in the previous process, to obtain with a very high yield lipophilized sterols that can be formulated into products to lower the cholesterol in blood. Moreover, some of these esters, in particular the one with linoleic acid, have shown to be active as antiproliferative agents, is reported in this paper. Now, from after extraction of the oil, we still have the fatted bran. This is the waste of the waste I mentioned, I was referring to at the beginning. From the fatted bran, we can still obtain proteins and some polysaccharides. Proteins are from the fatted bran can be hydrolyzed with silanesis or phytases to obtain hydrolyzed vegetable proteins that can be used in infant formulas, in surfactants, and also in flavor enhancers product. We focus on this last application, and as you can see here, by using two proteases, namely flavozyme or a mixture of alkylase and flavozyme, we could obtain this protein hydrolyzed that in their sensory profile show only sweet and umami tastes. This is very useful because quite often this protein hydrolysate show also a bitter taste, and this makes them not suitable for food formulation. So with these two hydrolyzed, we can propose these two products as an alternative to monosodium glutamate that, as you know, is very widespread. And this is particularly interesting if we observe that the free from monosodium glutamate market is growing quite fast, more or less 5% a year, and it's expected to grow again. Finally, I hope I have shown you that our approach fits well into the biorefinery model, as we produce both high volume, low added value products, bioproducts, such as composites and green building materials, and low volume, high added value ones, such as sterolesters and protein hydrolysates. Moreover, we also comply with the Food 2030 policy of the European Union, because of course we produce that ask for food production, but also for circularity, innovation, and of course climate tackling. Thank you very much for your attention.
Thank you, Nicoletta. Your presentation was extremely interesting, and I would like to ask you to comment on whether cost is still an issue for these processes you have shown us, in which such interesting products are produced, and with the properties that some are comparable and sometimes even better than other products with the same functionality. Are we still at the research level, or is industry ready to take these results, take over these results and use them in the market?
But some of these applications are, I should say, close to the market. For example, the green building materials produced from wool and straw have already been developed on a big scale, because the fact that they are both thermic and acoustic insulator make them suitable for palestras, how to say, gym, or other situation where sound insulation is suitable. And the production of a floor has already been carried out. So we are scaling up this kind of production. The cost, of course, the cost of this material is higher than that of polystyrol, but for some consumers, they show very big advantages, particularly from the environmental point of view. For other application, yes, we designed this project with a focus on the biorefinery model. So in this way, that's why we started from the oil, because if we can get some high added value product, this will allow the whole valorization to be cost effective, because it's the two or three products balance one each other. So we spend a lot to produce the protein hydrolysates, for example, but you recover this money from selling the green building material. So this is always a trade-off.
Yeah.
For this reason, it's better to extract more active compound or more molecules from a single waste.
Thank you.
I don't know if I asked your question.
Yeah.
Okay.
You answered. Thank you. So I think we are now ready to move to the third presentation given by Professor Daniele Dondi from University of Pavia, who will present on photosynthetic resins based on vegetable exhausted oils. Daniele, I will be able to present, you should by now.
Yes, thank you. So are you able to see my screen?
Yes, perfectly.
Okay, so thank you for this opportunity. So today I will speak about our last results of these photosensitive resins that is based on some vegetable oils, also exhausted oil. And so first of all, we have, everybody, so we have the plastic problem. So the earth is filled by non-biodegradable materials that are derived from non-renewable resources like the crude oil. So we have still this problem. And also, you know, now there is this new technology that is opening many possibilities for the future. That is the 3D printing. And I wish to just quickly tell you that the 3D printing, you have mainly two technologies that are on the market. The first one is in the filament printing, so you use some thermoplastic material. So you use the heat to melt down the material. The second one, maybe the less diffused, is the resin that uses the light for the production of the object. So I will speak about these last technologies because I think that it will open more possibilities for the future. So I don't want to stress too much how it works, this technology, but in this technology, you have a liquid resin that is a compound that is able to polymerize, that it means produce a solid object after the exposure to light that could be visible or ultraviolet. Some of these technologies can use some TLP, so like the digital projector, or they can use some displays, for example, LCD displays, such as you have on the mobile phones. But at the end, you have the printing by using the light. So depending on the resolution and the optics that you are using, you can achieve a very high precision in the printing. So precision that are far more higher with respect to precision obtainable with the other kind of technology. And so it's used for special making, for example, in jewelry or in other high impact technology. So while for the first technology, so for the first type of 3D printing, you could have some bioplastics, like for example the polylactic acid, or some matter B plastic that they are completely biodegradable. This is not the same for the resins that are currently used in the 3D printers that are using the light, that are called sometimes stereolithographics. So these 3D printers use resins that are derived by oil, and they are based by acrylates. Acrylates are very known compounds that could be harmful and also potentially allergenic. And also they have a bad smell, so better not to use these in home and use these in the ventilated environment. So we thought about to rethink about the monomers. So we wish to avoid to start from the crude oil, wish to use some renewable material, and so we move on vegetable oils. Vegetable oils by themselves, they are not possible to polymerize directly. And also you could have, so we tried successfully with many different vegetable oils, so even from a food or non-food application. But mainly we are concentrating on some wasted frying oil, because you know restaurants also in your home use oil and then after frying you throw away. So the destiny of the oil is to collect this and to transform this back to fuel, and you have this to produce the biodiesel, adding to the diesel. And so we wish to take to give this oil so another opportunities because after the fuel you will burn and you put again the carbon dioxide in the atmosphere. So we wish to take these oils, make another process to make it monomers, and that maybe you can decide to throw away, to destroy this and transform in the fuel or burn it for recovery of the energy. And so, but this is a challenge because, as I told you, the oils are okay. Maybe some you have some reactivities, but they are not active for the photopolymerization that we need inside the 3D printers. Also, we wish to move with respect to the sustainability and the green chemistry approach. So we don't want to produce waste. We wish to work as maximum as possible in the circular economy, reducing harmful product. So the process that we patented use, as I told you, so some renewable material. It could be waste or just vegetable oil material. It is not doesn't matter the origin, exactly origin of this, because we found this useful to start with different oils, but we are able to trigger the result. And also for the reaction, because we need to make some transformation of this oil, it cannot be used as is. So we wish to transform this compound in another more reactive compound. And in order to do that, we use some byproducts or other technologies. So the other reagents that we are using are also some waste compounds that are maybe useless, and also the destiny is always to be burnt. Our process does not use solvents, does not use toxic or expensive catalyst, and luckily for us, goes into the quantitative yields. It means almost totally % of recovery of the material, and we have the subproducts. So we have the byproduct that we have to make some waste management. And so the comparison is very hard because the technology on the market has stayed for many years. So acrylates are very well known, maybe almost 100 years. So the properties of the acrylates are so useful, so used, so well known. But we were able to find some competition with this technology. So we are able to find the process that has the same curing time with respect to the commercial resin. It means the exposure time is more or less the same. Also, it has a high resolution, and mainly this is important, low odor. So in the worst case, the odor remembers the odor of fried oil. And so these are some examples. So the formulation that we patented is we can change many parameters. One parameter that we can change easily is the amount of the dye that is inserted. We can change also the color of having different results. So that the concentration of the dye gives you an increase degree of the detail at the expense of the greater exposure time. As you can see, the object that we printed here, they are very small, so they are just a few centimeters tall, but you can see that the details are very high because here the layer that you can see are due to the printer that we are using or the resolution of the projector that we are using. So we haven't reached the highest resolution possible, because the highest resolution possible with this resin is maybe 10 microns, more or less. So also we tried this with commercial printers, so we are able to use this resin directly in the printers. The setup is very easy to find the proper condition for the printing, and also at the end of the printing, as usual, you must make some curing part, so you should ensure that material will last for a long time. Also, we started this curing period, so we are able to produce a resin. And so we measure also the mechanical properties of the resin. The resin more or less acts like an elastomer, but it's a very rigid elastomer, and it has a tensile strength and a derogation of bracket. They are similar to other materials that are already present on the market. And what is important for this project is also that we made a formulation, but we are able to tailor the formulation to suit the needs. So we can produce maybe harder resin or softer resin. And also we can think that we can choose the components for having a 3D printing for in the biological field, or the resin can be used as maybe outside the 3D printing if you want to make some coatings, some paints that are able to make the polymerization by using the light. Also, so the technology of the 3D printer uses normally the UV light, but by changing only the photosensitizer, we can make this to react to the visible light also. People doesn't want too much to work with the visible light because you have to keep the resin in the dark to avoid unwanted polymerization. And so why this technology is so important? Because we are taking some product as a waste, and we are transforming this into high impact product. So you know, the 3D printing technology is increasing day by day, and so it's growing. And nowadays also we have some printers that are cheap. So the 3D printer, they're using the light. Now they are cheap. They can be bought even at home, so they cost not too much. And so this technology for sure in the future will have a bit higher impact. We expect even to the action. So at the end, so we wish to, with this small contribute for the plastic technology. So we can make a summary of the strength of our proposal. The first one is for sure the use of raw material that come from renewable sources, even waste sources. And the raw materials are easy to find because you have many industries that they are able to collect the oil and to transfer this high amount of oil for the, I told you already, for the production of biodiesel. And also the transformation process that is used produce almost no waste, and the cost of production of this material is quite low, so it's comparable to the material that are already present on the market. So the highest cost of the material is the photosensitizer used, that is the same type of that one that is used in the other commercial resins based on acrylates. So this is not written here, but we are not using the acrylates, so we wish to avoid the maximum as possible the possibility to have the material that can cause some allergy or other unwanted reactions. So thank you for your attention. Also, I wish to thank the U4I that give us the opportunity to finalize this project, to give this from the academic to some in a technological industrial point of view. So with this contribute, we are able to make the patent. Also, I thank the University of Pavia for this.
Thank you, Daniele. I would like to ask you to comment. Well, I know the research part can be said to be almost concluded for this project, and you mentioned sort of two kind of application. 3D printing specific and paintings, other kind of application. Would you like to comment on what would be needed to go to the market in either sectors?
Okay, so we need to have a contact with the stakeholders. So we are able, in that case, we are able to finalize the formulation in order to meet the requirements. We already are able to produce some quantities that for the lab scale is quite big, because we are able to produce up to 10 kilograms of resin by week. For the lab scale is quite big, but it's for sure sufficient to make tests if we make some collaboration. So we work with the industries that can ask us maybe to make some specific tests or to meet some characteristics that they need.
Thank you. I think this presentation concluded the more technical part of the webinar. I would like to remind the attendees that you can comment on this specific technology, but also other technologies. You can see them, they are called Technology Plus, and you can give your feedback on each of them, and every feedback will be welcomed. We can move to the more to some insight on the economic part of this research, and we can welcome Dr. Salvatore, business analyst and startup planner, who will give a presentation of a new business model for nutraceuticals from organic waste. So Alessandro, I will be able to just give me a minute. Well, now you are able to share your screen. Perfect. We can see your presentation.
Okay. So, first of all, thank you for inviting me. I'm a business planner, and I'm going to talk about the development and planning of the business idea Enrico Doria mentioned before. I'm referring to nutraceuticals product for one specific reason, is that although Enrico told us that the product is suitable for several uses in several markets, several industries, the market analysis suggests that very likely the biggest use for this product we are going to talk about is for a food supplement. However, just to summarize the story behind, at the very beginning there was a problem: how to use vegetable waste. The research activity Enrico has just presented has given the chance to find a possible solution to this issue. And also, it has generated a possible business chance, a spin-off. I joined the project at this point with a specific task of planning and developing the idea. Planning a business is like building a house. We have foundations, which are made up by 4 pillars: the knowledge, the technology, the business idea, and the market. And the house we can build above the pillars is the business model. The business model is not what to do, but how to do it. And this is very crucial in a planning process. Just give a very short look at the pillars we have. As far as the knowledge is concerned, we have qualified people, academic level competencies. We have a technology which has been developed through the research activity Enrico has shown. And this technology, this methodology is proved to be efficient by a technical point of view. Now we have to see whether it's also efficient from the economic point of view. And then the business idea: to extract substances for nutraceuticals and also other possible uses from vegetable waste. Last but not least, the market tells us that a need exists. And the market is a growing market with interesting growing rates. What does planning a business model mean? Means basically to find a way to be innovative and somehow different from what competitors do. The first step after the market studies, then, just look at what the competitors do. And looking at them, we can see that a sort of standard model can be actually identified. When I say standard, I don't mean it's used by anyone, but I mean that some elements, recurring elements, can be actually identified. This table here summarizes the main elements we can find looking at this kind of standard model. It's interesting to note that most companies take the raw materials from plantation, and we had no chance to find experiences, projects, and companies deriving the raw materials from vegetable waste. So this is something new for this industry. Other things we understood from the market analysis is that the market can be segmented, and the segmentation is made from the quality of extraction and the purity of the product. Within each segment, the product cannot be differentiated like, for example, other products like cars or like garments. Product with the same quality level is almost similar to each other. So the companies do try to find differentiation, not for the product, but from the process and from the business model. Another thing we saw from the market analysis that almost all companies consider themselves as sustainable companies. But we already consider that no one is using vegetable waste as a source for raw materials. Differentiation is found, for example, in the nature of companies. Some are manufacturing companies producing ingredients for nutraceuticals, and some are just distribution companies. Some companies also offer consulting services to the nutraceutical producers. Some of them claim to use biological plantations. A couple of interesting cases are given by the Dem Biotech company, which produces molecules from in vitro cultures, not from plantations. And the Biosphere project, it's another spin-off, claiming a top scientific quality of the process and the product. So positioning itself in the top segment of the market. What kind of requirements must be respected when planning, when designing a business model? We already said that the business model must be somehow different from the competitors, or from at least from most of them. Must be based on strengths and must be focused on the elements which has the chance to generate value, and as a consequence of this, the business model must be potentially profitable. So let's give a look of just summarizing what the business model we have developed envisage. First, and this is the most important element, raw material does not come from plantation, but from vegetable waste. And this is a very distinctive feature of this project. Another point is that we decided, or better, the project team, the scientific project team, decided to focus on the initial phase of the production process, excluding the final extraction and focusing on the pre-treatment, because the research activity Enrico described is mainly focused on this part of the production process. So the output is not the finished ingredient used by the nutraceutical industry, but a semi-finished product which has advantages in terms of efficiency, is more efficient, is more sustainable than the traditional method. As a further consequence, customers are not companies producing nutraceuticals and food supplements, but companies producing ingredients for nutraceuticals. Here in this table can summarize differences between the so-called standard model and the BioRestart project model. The product is different. We are not deciding to produce botanical extract, but the semi-finished product for botanical extract. We are not using plants from plantations, but vegetable waste. We focus on the pre-treatment, excluding, at least at the moment, the final extraction, and as a consequence, the type of customers changes. Planning, designing a different business model, it means to find some feature which must be very distinctive, must have a meaning in terms of strategy, must have a value in terms of strategy. The first feature, the use of vegetable waste, it's not just a matter of image, of a matter of value. This has also an important value in economic terms. As long as this resource is much cheaper than plants coming from plantations, and we have big quantities for this. So the BioRestart product can claim to be really sustainable. And I can say that maybe better than what other companies do, as long as plantation imply the use of land and the consumption of water. So plantation has a remarkable environmental impact. In this case, using the organic waste, we have a positive impact, environmental impact. Focusing on the pre-treatment means to reduce the financial need and the investment need, and which is an interesting thing for a startup. And the changes we have seen, the change we have seen in the type of customers might have the chance to reduce the competitive pressure on the project. We are not competing to the same customers as most companies currently do. Of course, we cannot say that this model is a perfect one, is the best option. Only the market can tell us whether this is the best option. Of course, we have some drawbacks. It's like planning a business model is like making a gamble somehow. And in this case, it's the gamble is because this business model has no previous experiences. It's something brand new for this market. And we cannot be sure whether the customers will perceive clearly the advantages they will have by buying, by purchasing this semi-finished product. So the strategy is to go to the market with this, let's say, preliminary version of the project and test the market to see whether the response from the market is a good one. In this case, we can go on with this business model. Otherwise, as a good planning process is supposed to do, we will go back revising the business model. Planning is never over. is always an open process. We must be ready to change something whenever the market say that the choices are not suitable, are not correct. However, we have made an evaluation of the business model according to some ex-ante criteria. If the business model is a logical one, is complete, is coherent, is differentiated, it's innovative, can generate a low break-even point and a low financial need, okay, then those are the criteria that can make us think that the business model at least has design is a good option. But of course, the market is the king in this situation, and the market will tell us whether the option is a good one or something will is needed to be revised. So the house is designed. Now we have to check whether it's a really comfortable one. Thanks a lot.
Thank you, Alessandro. Yeah, your presentation was extremely interesting. I would like you to comment on the specificity and the challenges posed you by dealing with the researcher and the public university policies. Did you find some specific difficulty or well? Just comment on that.
Not specifically. I mean, no. I'm honest. What I can say is that when confronting with a group of researchers, the researcher team, we had to understand each other. That was the main issue. I have an economic background. People like I was talking with, Enrico and the other colleagues, has a scientific background. And I don't know many things they know and vice versa. So that was the main issue, to find a common ground in order to develop the project. I asked them to help me to understand the technology and the methodology, and I tried to transfer to them the basic concept in planning a business. That was the main issue. But I actually, just to answer your question, I didn't find, I'm honest when I say that, I didn't find any trouble in dealing with universities bodies anyway.
Well, thank you. Thank you again. And well, we are ready to move to the last presentation, which will be given by Elena Chiti and Gaia Liberatori from GM Ambiente ed Energia. They will share the presentation. Just allow me to cancel. Okay, well. So now you can present.
Vai, ok. No,
I cannot see you. You have, okay, well, okay. Perfect.
Hi, good afternoon. It's a pleasure.
Go ahead.
Here. So, okay. My name is Elena Chieti. I am the Sales and Marketing Director for GM Ambiente Energia, which is a company based in Rome, operating across all over Italy and providing public and private companies with waste management services and energy and environmental consulting. Here, there is also my colleague Gaia Liberatori.
Hello, good afternoon.
My name is Gaia Liberatori, and I work as Technical Director of GM Ambiente ed Energia. Our company operates as an intermediary in the waste sector, and we connecting the customer, the producer of waste, with disposal plant. Also, we are an environmental consultant and specialized in the green economy and circular economy sector. Okay, actually, our company is dealing with different kind of clients. We provide our services to different clusters of clients. That means that circular economy project can be applied in any kind of industries. For example, we deal with pharmaceutical and chemical and plastic companies, travel companies, agri-food industry companies as well. And the last one is the field that we are going to investigate today with you. Let's say that circular economy project can aim different kind of scopes. First of all, of course, to decrease the environmental impact of our client business, and it can be pursued in different ways. We are going to see what does it mean. And secondly, to reduce or let's say improve the cost management of waste treatment and energy consumption from different point of view. And third, but not less important, is to increase the brand value and the green perception of our client from end users point of view, stakeholders point of view, and in general bond market. The methodology that we apply to carry out our circular economy project is always the same, and it's composed by the following steps. First of all, we do an assessment of the circular level of our company, of our client, sorry, from a 36-degree approach, going from procurement phase, coming through the production process, the after production process, sales process, after sale phase, and simultaneously considering the waste management process and energy consumption. After that, we decide with our clients to settle down the object of our project, and there are the ones that I mentioned before. Of course, the goals are also related to the budget that our clients can address to the circular economy activities. After that, we define the long-term circular strategy, and we also decline it in different short-term operational activities, and we take care to carry out that in order to achieve our goals. After this, we can also take care of green, to take care of what we used to call green marketing. That means pre and post communication, online and offline communication of circular economy activities in a proper way, in order to let stakeholders, consumers, and market in general appreciate the effort of our clients. So we can also, after mention and going through some case studies, we will recap the most important functional and economical benefits related to our circular economy activities. So my colleague is going to investigate our case studies.
Okay. As told by Elena, we are currently coordinating several green projects focusing on circular economy activities in the agri-food industry. They are all dealing with conversation of waste coming from the processing of agricultural products to get value-added secondary raw materials. For example, agri-food production not suitable to the end user market can be turned into boost that it's used to grow water cleaning bacteria, or compost that reused as fertilizer, or faster restoration of bumpy area, or green energy such as biomethane or biogas, often used to satisfy internal energy demand and cut down the energy cost of all the plants. In this case, we are also truly interested in the recovery rice alks residues. Actually, this specific kind of waste is the output of the pearling process, a batch process that removes the grumella of rice grain, husk, and chaff in order to get it measurable. Now we are aiming to value it in two different ways. The first one is start from its oil and vegetable fats. Can be addressed to the nutraceutical industry. And also it can be interesting in insert in the process of production of sporting flooring, or in the production of insulating materials, or design furniture semi-components. Those new applications need first to be tested, and now we are working together with the CNR and the Dr. Ravasio in order to do it possible.
Okay, so in general, we can say that there are two main areas of benefits from circular economy activities for our clients. Functional area is related to the better management of logistics, because in general, volume of waste is reduced. And there is an effective improvement in the management of warehouse and ecological sites for our clients. For example, when we turn ARC into another components, the storage of this waste is dramatically reduced. And from another point of view, functional point of view, there is, of course, the increasing of corporate sustainability that can be reported annually based in the balance sheet and the stakeholders documentation. Of course, there is the first important aspect, the reduction of environmental impact of our client businesses. From an economic point of view, there are several nice aspects for our clients that, of course, are very important to them. First of all, there is a reduction of cost of the cost of waste management, because, for example, coming from turning the waste into the second value-added raw materials and selling it to third parties to leverage these new raw materials can increase revenues for our clients, and at the same time reduce the cost of treatment of this kind of waste, because it's not more a waste. And from another point of view, there is an increase in revenue coming from the growth of brand value that is translated into the perception and the value that customers and stakeholders given to our clients. And this actually we are always challenged by our clients to find new project and new circular economy activities to develop. That means that the market is really mature, or is going to be mature to focus on it. So let's say that we are feel free to ask questions or contact us to describe if you have any idea or particular needs in these terms, and we will be very glad to listen to you and support you from this point of view. Thanks.
Thanks.
Thank you, both of you. I don't see right now any questions, but I think that the organizer will be able to convey them in case to me or to you personally. I have a question, actually the same one I got for Dr. Salvatore. We met through Dr. Ravasio because of of your involvement in the RISE project. How was your experience within a project with so many researchers and well, also public research entity?
You mean from project management point of view? Okay. We play as an intermediator, so we connect our clients. We were addressed by our clients to find a nice and value-added project to leverage this kind of waste. So we met Dr. Ravasio, which was connected with, which is actually connected to several different companies and private realities. So it was quite easy to coordinate all these entities, let's say. Now we are actually we are trying to find also some how can I say support, financial support from the government, because there are new law and new support coming from the economic environment transition. So let's hope to find some financial support also.
Maybe within this audience. Thank you. Yeah, so I would like the other speaker to join me in saying goodbye to our audience. Not sure, I think most of them are still here. Well, okay, and so I would like to thank you all, our speakers who brought their expertise to this webinar, which I hope has been interesting for our audience. I know that this webinar will be able to be listened again, and will be on the website of the TechShare Day. Tomorrow will be the last day, last of the 3 days, and I invite you all to enlist for the 3 webinars that will be given tomorrow. Again, you can comment on the technologies and give your feedback on them. So thank you, and have a nice evening.
Thank you. Thank you.
Thank you.
Thank you. Bye-bye.